Magnus, look what I got over here. I got some sugar. Wait. No, Magnus. No!
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
Okay, I'm here with my buddies Magnus, Glucose, Smash! And of course, Francesco, because he's going to overview making sure we have a good controlled experiment. And I have some material, so we're gonna test ATP, right? Like how much ATP. Now, based on what we've researched, right? You need ATP all the time. So I'm gonna test to see how much ATP do I make when I'm not doing anything, right? And then we've researched that you can get some ATP quickly through anaerobic respiration. So we're gonna measure how much ATP I can get anaerobically. And then we've learned that we should get almost, 18 times, like 18 times more if we go aerobically. So we'll test that today, and we're gonna use a couple of different chemistry tricks to do that, which I'll explain right now. All right, so here's a little bit of the chemistry we're going to do, right? We wanna measure how much ATP. Now ATP is pretty hard to measure, but what's easy to measure is the waste product of air respiration, carbon dioxide. That's actually really easy to measure. So that's what we're gonna measure, knowing that you only get carbon dioxide if you make ATP, right? Like, it's like you only get the waste. You only get the waste if you made the stuff, the good stuff, right? If you don't make any good stuff, you don't get any waste. All right, so the chemistry of it is water is really good at capturing dissolved chemicals. So we're going to dissolve carbon dioxide into water. And what happens is that water coming out of the tap is usually neutral. When I add carbon dioxide to it, it becomes carbonated, but also acid. Okay? And we're going to use a chemical called an indicator. You know, like if you guys ever have like a pool or something at home and you have to test its pH, or if you have to you just use these little color strips, right? And they tell you that's all we're going to do. We're going to look for a change in color. So I'm going to use an indicator, which should change color in the presence of acid. And then we're going to add a base to neutralize the mixture again. And so it should turn back to the original color, right? Like it'll be no color, it'll change color, and then we'll change it back to the color it originally was. That's the chemistry, okay, that's involved with this stuff. All right, and so it's going to look something like this, but ultimately what we're going to do is we're just going to count how many drops of the base. That should tell us how much carbon dioxide we made. Okay, so that's what we're going to do. I'm anticipating that, right, the more ATP I make, the longer it'll take to change color again. All right, let's get back to it. All right, so we're gonna do an indication. This is actually called like a little titration experiment. Okay, so what we're gonna do is we're gonna capture carbon dioxide, which we know is a waste product of doing cellular respiration. You only make carbon dioxide if you're making ATP. And then we're gonna test to see how much carbon dioxide was in each of these containers, and that will, of course, will let us know how much ATP was made, right? The more CO2, the more ATP. So some controlled variables. I'm gonna start with, right? I'm gonna put 100 milliliters of water into this cup. This is where I'm gonna capture all of my carbon dioxide. And I'm gonna use a straw to breathe into the cup. And I'll breathe into the cup for like a minute. Okay, some other controlled variables. I have 3 test tubes. They're all the same size. And they each have the same amount of the indicator, phenol red, right? This is the indicator solution. Same amount of size. And what we'll do is we'll add the same amount of carbonated water to them. And we'll let it mix them for the same amount of time, and then we're gonna measure how long it takes to turn them from one color to the next. The longer it takes, the more ATP. All right, so the first thing we're gonna do is I'm gonna test Mr. Kobach doing nothing, just existing. Here I am, just existing. Ready? Okay. Right, I'm breathing out through the straw. And the water in this cup is capturing the carbon dioxide I'm making. So I'm gonna do that for a minute. All right, so I breathed for a minute after doing nothing. And remember, it was red. When I added the carbonated water, look, it's changed color. That's an indicator that there's carbon dioxide present. So what I'm going to do next is we're gonna see how much carbon dioxide is actually present by trying to turn this from orange back to a pinkish red again. All right, so here's my test tube that I turned from red to kind of orangey. This is going to tell me how much ATP I need just to stay alive. Okay, so I'm going to add, again, this is sodium bicarbonate. It's a base, and you'll see when I add it, one drop, you'll see it starts to turn the orange back to red. So there's one drop. Okay, 2 drops. I'm going to swirl it a little bit to make sure it mixes up. And I'm going to keep adding drops till it doesn't get any more red. 2 drops. 2 drops. I think it needs still a little orangey at the top, and 1 more drop. 3 drops is going to be how much ATP, well, how much carbon dioxide I made doing nothing. I still had to make some ATP. Now, I'm going to exercise. You know what I think I'm gonna do? I'm gonna dance. I'm gonna dance for like 25 seconds. I want enough to really, need some energy, but not so long enough that my circulatory system can catch up. And then we're gonna see how much ATP I make. All right, whew. Now I'm gonna dance one more time, but this time I'm gonna go for 2 minutes, 2 whole minutes. That should be long enough where I should start to be able to make ATP aerobically, and I should have a lot more, I should make a lot more carbon dioxide, right? So that's what we're going to test. All right, now we got to test the other 2. Okay, so I'm going to add drops until it changes all the way back to red, and that we'll see. All right, so I'm going to start adding drops. All right, so we got some results. 2 drops. 10 drops. 40 drops. What we're going to do now in the part 2 is I'm going to do a mini lab report. So there'll be a few Google slides for you to answer. I think I'm going to put 3. Okay, the first one will be you tell me what cellular respiration is. Okay, the second one will be I'll give you a copy of the results, a graph, and you're going to tell me what that means. And then third one was going to be where you tell me the difference between aerobic and anaerobic respiration. So that's your task today, your part 2. And your part 3 is going to be another ed puzzle, of course. All right, thanks for doing some science with me. We would have done this together in class, but COVID. Oh, by the way, look at my mask. Powered by coffee and mitochondria. Get it? Get it? Mitochondria. Get it?
Hey, how's everybody doing today? I'm feeling great.